All right, let's try to finally finish this lesson. It's part C. And I got to change my little writing thing here. Pink to start off with? I never start off with pink. Maybe if I do an arc or something like that, I'll use the pink. I'll use the pink for it. No. So yesterday we finished part B. We found the what do you call it? The angle. We did find the angle, correct? Theta. All right. What was the angle? 60 degrees. Okay. Just making sure that you were watching. So let's do part C. I need to draw a circle again. Let's see. I might have a circle somewhere. Oh, look at this. I got inscribed circles. Do I have just a circle by itself? No. So I'll just draw one. Let's see. I said we would do a different color when we start labeling things on this circle. Okay. All right, so there's the center of the circle. I'm going to draw it the way I have in my notes. I guess it looks like this in the book. It's probably why I did it like this in the notes. All right, so there we go. Okay, so you don't know that angle. That's theta. And you don't know this radius. All right, but you do know something else. You guys said you want to use pink, so I'll use pink. Nope. All right, so let's see if I can stay on track. It's not that easy with this little graphing tablet. All right. Do you see that right there? So they tell you that is 330 degrees. All right, so that should make something pop out at you. Right? There's two unknowns there. Now there should only be one unknown. Right, theta is 30 degrees. Good. Let's just put that in there right now. So that's the first thing that we should recognize. Right? So if that's 330, you know how we got that, right? 360 minus 330. Okay. So right off the bat, we know that. And they tell you the measure of this little arc right here. They tell you that it's 4 feet. I'll just put a 4, okay? We'll just remember at the end to put feet, okay? And what do we want to find? Well, what's the only variable? We want to find r. So, do you remember our little formula? Let's write that down. What was it start with? Length equals. Okay. Oh, I'm sorry. Did the 360. So, right, it's theta over 360, and that's 2 pi r, okay, times 2 pi r. Why 2 pi r? Because that's not the radius, that's the circumference of the whole entire circle, correct? That's 2 pi r. What's the theta over 360 have to deal with? It's just this much of the circle, right? We're not finding 360 degrees out of 360. We're finding only what? 30 degrees out of the whole circle, which is 360 degrees, okay? So from there to there, okay, it's a portion, it's a part of the whole entire circle. How much of it? It's theta over 360, whatever that is, okay? Now, we know theta, don't we? All right, and we know the L, don't we? All right, and what are we going to solve for? R, so let's do that. So L, so what is L? It's the length of the arc, right? So that's 4 equals, what's our theta? That's our central angle, so it's 30 over 360, and it's 2, and it's pi, and it's r, because we don't know what r is. So that's what we're going to solve for right there. So our geometry is over. Now it's just math, okay? It's just algebra. So let's get r by itself. Well, let's do this first. Wouldn't you rather simplify that? Yeah, so that goes into that. 3 goes into 36. How many? 3 goes into 3 once. 3 goes into 36 12 times. Okay? If you wanted, you could do this several different ways, but if you wanted to, look, 12's on the bottom, 2's on top. You could just go ahead and do that now, couldn't you? All right, so you're right. So this 2 divides into this 12, what? 6 times. So it's 1/6. Let's write it real nice. 4 equals what? 1/6 pi r. Everybody see the math? There's a couple ways you could have approached this. This is just the way I looked at it, and I said, this is the way I want to do it, okay? So what do you want to get rid of now? Let's get rid of the 1/6. Okay, that's kind of ugly, isn't it? So let's get rid of that. How do I get rid of a fraction if it's being multiplied? You could divide, but you'd be dividing by 1/6. Okay, but what's the same thing as dividing? It's multiplying by the reciprocal. So that's an easier way to do it. And you are right. You could divide by 1/6. But then you're going to get 4 divided by 1/6. It's not 4 divided by 6. It's 4 divided by 1/6. That's kind of weird. You can do it, but it's a lot easier just to do this. Watch. I'm going to multiply this by 6. So what happens? Cancels out. So what do I have to do to this side? Multiply that by 6. See that? That cancels. And now I've got what? 24 equals pi times r. Well, pi is not a variable, is it? It's a number that I actually know. So r is my variable, so how do I get rid of the pi? It's being multiplied. How do I get rid of something that's being multiplied? Divide, right. It's not a fraction, so I don't have to divide by the reciprocal or anything. So I just divide. So I divide this by pi, divide this by pi, that cancels, and that's basically my answer. Okay, if I wanted to keep it like that, I guess I would be okay. But that doesn't make much sense to us, does it? So what could I do to figure out like the approximation, the decimal approximation? Put it where? In a calculator. So what's the math? It's 24 divided by 3.14. Now your calculators do have pi buttons on it, but what did I say about that? Just put in 3.14, just so we can stay consistent, all right? So we put it in the calculator, and you should get, actually I should get rid of that equals. Why am I picky on that? Because what? Because r isn't exactly equal to this number. It's approximately equal because it's going to have some big old long decimal after it, right? But we're just going to round it to one decimal place, and it comes out to 7.6. Did I do that in my head? No. All right, I did that using a calculator. What's that? This is 8.3. Yes. Hopefully, it's the last time we do 8.3. And it is in feet, right? I haven't been including the feet, but we'll do it here. So that's the radius. So the radius is approximately 7.6 feet. It's not too hard, is it? So there's all kinds of different things you could solve for using this formula right there. All right? All right, let's move on. Let's do something a little bit more involved. This is example 3. Example 3. All right, circle again. Let's put it over here. And I like to put the center of the circle. And we're going to put a couple radii, one there. And another one, let's say there. Okay. And they tell you a couple things. Let's label it. That's X. This is Y. And this is U. I'm going to slide it over to the left a little bit because you can see it on the screen. But when I put it on YouTube, when I watch it on TV, it seems like it cuts off the edges a little bit. So I'll do that. All right. And let's see. What are they? The perimeter. And they tell you the radius is 12. So if that's 12, what's this? That's 12. And they tell you the angle is 120 degrees. And they ask you to find this. They want you to find the perimeter of sector XUY and segment, so it's two answers, segment XY. I could have just put line segment over top of it, but that's how I wrote it in my notes, so that's how we're going to do it. So, let's see what I want to do here. Yeah, find the perimeter of those. Segment, right. Now, what is the segment? Actually, I guess I could have done that, but this is the way they did it. What is the segment? You remember the sector and segment thing? No. The sector is I'll erase this after I'm done, but watch. It's all of this. Do you see that? If I shaded everything in up to the edges, that's the sector. Okay, so it says find the perimeter of that sector. So what am I finding? I'm finding the 12. What else? The 12 and what? The length of that arc right there. Okay, and we've talked about how to find the length of the arc. Okay, we just did an example like that. Everybody with me on that? So what does it mean to find the segment? Where is the segment? It is a chord, correct, from X to Y, all right? And so what is the segment? Let's do this in the same color just to keep it the same. So this right here, okay, again, if it's all colored in, you get the idea. If it's all shaded in, okay, that is the, we want to find the perimeter of that segment. So what's the perimeter of that? Hold on. 4. Give me a sec. I'm looking at this. Perimeter of the sector, 8 pi and 24. Where did I get that 24 from? Hold on. A third of 24 pi. The 24. All right. Two sides are 12 and 12. Oh, I know what I did. It's the same problem, but I split it into two different things, and I was thinking it was a different problem. Okay, yeah, we're good. All right, now the segment's going to be a little more complicated. All right, so watch. What we need to do, if I want to find the perimeter of the segment, okay, this little area right here, it's shaded in pink, is the segment. What's the perimeter of it? Well, it's from X to Y. We got to figure that out. That's a little complicated, I'll tell you right now, okay? And we got to figure out whatever that arc is. Okay, and we've already figured out the arc if we do the sector. So that shouldn't be too bad, except for the XY. The XY is a little bit more complicated. And it doesn't look like we're going to be able to finish that today either. We'll at least do the sector, okay? So I'm not even going to worry about that one right there. So what we're going to do, just don't worry about that. Let's just worry about what we're doing right now, okay? Concentrate on what's right in front of you. So look, this is 12 and this is 12. So let's just write it down. 12 plus 12, that's what? That's 24, okay? So that was easy, okay? Because again, we're finding perimeter. So we're finding this one, and this arc. We got to find arc XY. So we just kind of did that. We already know how to do that, don't we? All right, so how do we find the arc? So the length of the arc is equal to theta over what? 360. In this case, it's 120 over 360. Okay, times pi times what? I'm sorry, you forgot the 2, didn't I? 2 pi r. So let's put the 2 on top and then like that. So all I do is just do this math, then add that to 24, and I'm good to go. So that was pretty easy. Finding the sector is easy. Finding that segment right there, little tougher. We might have time if we do this quick. So let's see, let's cancel some stuff out. That goes into that. Let's see, 12 goes into 12 once. 12 goes into that what? 3 times? Did I do that right? Oops, I forgot the R, didn't I? So the R was what? 12. Okay, 12 times 2 is what? 24. And then that 3 goes into this 24. How many times? 8. Everybody see that? It's a little bit of a mess. You can cancel out however you want to do it, but that's how I did it. And so what are you left with? You're still left with pi, and you're left with what? 8. So what is the length of that? It's 8 pi. And if you wanted to, you could put it into a calculator. So if you want, let's do the perimeter though. What's the perimeter? So this thing right here is 8 pi from X all the way to Y. 8 times 3.14, right? Everybody got that? Okay, so what's the perimeter? The perimeter, I'll do it in a different color just so we can see it. What is the perimeter? Well, it's this plus this arc. Oops, I missed it a little bit. You get the idea, okay? It's supposed to stay along the arc. So that's what we're trying to find. So we already got the 12 and the 12, which is what? 24 plus, what's the other part of it? What's the arc part? It's 8 pi. If you want to leave it like that, it's perfectly fine. I'd be more than happy if you just left it like that. If you really, really wanted to, and some people really have a problem with leaving their answer like this, but if you really wanted to, you could do what else to it? Put it into calculator. Okay, if you put it into a calculator, you get 49.1. And this was all, I didn't tell you what it was in. It was in feet, correct. So that would be feet. You'd also have to put the feet there. Don't forget that, okay? So you could leave your answer like that, or you could leave the answer like that. I kind of made a little mistake here. What was my little mistake? It's not that big of a deal. I wouldn't mark off for it. Yeah, it's not technically equals. This one's squiggly. That one's equal. Why is that one equal? Because, yeah, it's the word I use a lot. It's a what kind of an answer? It's not an approximation. It's an exact answer. It's an exact answer, okay? So this answer right here is exact. This answer right here is what? An approximation, okay? I'll just put approx, okay? I would accept either answer. I'd be fine with that. We good? All right, so what we need to do now, I don't know if we have enough time for this. Man, why is it taking me 4 days to do one lesson? This is stupid. Anyway. So now what we need to do is we need to find that pink one right there, right? Because now what we're doing is we're finding the segment. Everybody see that? So now we need to find segment XY, which means it's from here, the perimeter of segment XY. So it's from here to here to here. Well, I already know that's 8 pi, so I'm halfway there, right? All I got to do is find that line segment XY. So how in the world am I going to do that? Well, I'm glad you asked. Did you ask? Okay. So what we're going to do is this. We're going to split this up into two triangles. We're going to make that perpendicular. If we make that perpendicular, we know a few things. These two triangles are going to be congruent to each other. Remember, that whole thing is 120. So what's this angle right here? That's 60. What's this angle if I make it perpendicular? That's 90. So what's this little angle right here going to be? It's going to be 30. Everybody with me on that? Okay, so what do we want to find? We want to find this. We want to find from here to here. If we can find that, then we just double it and we got the whole length and we're good to go. How do I find from here to here? It's a 30, 60, 90 triangle. It's opposite the 60, so you tell me. Is it? Yes, it is. It's opposite the 60, so that's the long side. What is the 12? The 12 is the what? Hypotenuse. What can we find very, very easily? We could find the short side. What's the short side going to be? Easy math. 6, right, because the short side's half of the hypotenuse. Now, this side right here is what? It's 6 square root of 3. That's right. All right, because the long side is the square root of 3 times the short side. We did that just, what, yesterday, day before, something like that. We did something like that. Didn't we do? Yeah, we did 30, 60, 90 triangle. We didn't? Maybe it was the other class. I think it might have been the other class because they just started this chapter. Anyway, so that's 6 square root of 3. So this is also 6 square root of 3. What is the whole entire length from x to y? It's 12 square root of 3. Very good. So what's my answer? Look, we're going to finish this today. What is my answer for the perimeter of the segment from x to y straight and then around the curve? It's 12 square root of 3, what? Plus 8 pi. That's it. And that's the perimeter. All right? They rigged this thing for you, didn't they? To make that 60, and so it's a 30, 60, 90 triangle. So that was nice of them. There's going to be, when you get into Algebra 2, hopefully, at the end of Algebra 2, you'll learn how to solve these without doing this. It's called the law of sines, law of cosines. So it's something that you will eventually be able to do, no matter what that angle is. It doesn't have to be like a perfect 120 to make that 60 and 30 and 90, okay? There's another way to do it. But for right now, they rigged it for you. They made it within the realm of possibility of solving for it, and that's the perimeter. And then again, obviously, you can do what? Could put it into a calculator, and you would have gotten approximately 45.9. Again, it's the same problem. They're all in feet, so that would be feet. So that's the perimeter of the segment. This is the perimeter of the sector, okay? And what do you think is going to be the bigger one? The bigger one's going to be the sector, isn't it? Okay, because this and this is going to be bigger than that, right? So this plus 8 pi is going to be bigger. It's not a whole lot bigger, is it? Look, 49.1, 45.9. It's not a whole lot bigger, but it is. All right, look at that. We finished. Right on time. Perfect. Thank goodness. So whatever the homework was, I gave you a lesson plan.
It's 2 to 16.
2 to 16. Okay, so there you go. I'll write it down. It's 2 to 16, so you should be able to do every single one of those. You've probably done a few of these already, have you?
Yeah.
All right, so you shouldn't have to do all of them tonight. But get it done. I'll collect it tomorrow.